quieting it down right away. Thank you. First of all, good morning.
Good morning.
It's a beautiful sunny day in Alabama. Good morning.
Good morning.
Oh, much better, thank you. My name is Brad Caskey, and I serve as the Provost and Vice President for Academic Affairs. And I'm excited to have you here for today's Provost Forum. As we begin, I'm going to do a little public service announcement. Anyone kind of seated in the back towards that camera area. It is a live camera with a live mic, and so we want to pick up the speaker and not your conversation on Twitter, which actually we wouldn't hear, but if you said it, we would hear it. So be a little careful back here talking to your partners and neighbors. It's now my distinct pleasure to introduce today's Provost Forum, presented by Dr. Andy Gannon. Dr. Gannon is a professor of biology who joined Birmingham-Southern College in 1995. His academic credentials include a BA from the University of South Florida, an MS and PhD from the University of Florida. His research interests include comparative physiology of crustaceans, control of ventilation in terrestrial crabs, and wetland and coral reef ecology. All right. Please join me in a round of applause as we bring Dr. Gannon to the podium for his presentation, which was originally titled The Impact of Altered Salinity Regimes on Blue Crabs, Callinectes sapidus of the Apalachicola Estuary, which apparently was too much, so now we have a new title, simpler: Water Wars, Will the Apalachicola Blue Crab Survive? Dr. Gannon.
Thank you. I'm going to try and project rather than use the microphones because I'm not good with microphones. I hold them too close or I hold them too far away. So people in the back have promised to let me know if I'm not loud enough. So here is the Apalachicola River, and here is Apalachicola. St. George Island is familiar to many of you vacationers. St. Joe's Peninsula, Mexico Beach was there. So just to situate you with the place, now I'm going to give you an overview of the talk. I'm going to talk about the water wars first, and yes, we are at war. I'm going to talk about the salinity regimes, how the water wars have affected them in the Apalachicola Estuary. I'm going to introduce you to blue crabs, and this is our primary research question. Are altered salinity patterns in Apalachicola affecting the crab population? I'll tell you about our research methods, some of our results, and hopefully I'll have time to get to future directions. So here's the water wars, tri-state, Alabama, Georgia, and Florida. So you're in this, whether you like it or not. There's two major basins here. The ACT basin, which includes the Alabama, Coosa, and Tallapoosa rivers, and the ACF basin, which is what we're going to focus on, includes the Apalachicola, Chattahoochee, and the Flint rivers. The Chattahoochee and Flint rivers come together at the Florida-Georgia border to form the Apalachicola River. And this is our focus. But Atlanta is at the headwaters of both of these river basins. And Atlanta is very big, approaching 6 million people, at least the metro area. And Atlanta is very thirsty. There's a lot of competing interests for all the water. And they have a relatively good rainfall. You'd think there'd be lots of water in Atlanta, but they have a granite bedrock. So they don't have any aquifer or underground water storage, so they only rely on surface water. And as their population has grown, they've taken more and more of the water so that there's less and less water getting downstream. The Woodruff Dam is right on the border, and the Woodruff Dam controls how much water flows and gets down to the Apalachicola. Now you could put these competing interests in any different order for priorities. The Corps of Engineers might put hydropower, flood control, and navigation at the top of their list. Environmentalists would have a different viewpoint, and economic developers would have a different viewpoint. But I do want to point out that almost everybody would put commercial wildlife at the bottom of the list. Endangered wildlife at least has legal standing. But commercial things like oysters and crabs, they have no advocates and they have no rights. So Alabama's role in the water wars were greatly affected, right? Both basins include parts of Alabama. But Florida and Georgia have been the primary litigants for a couple of reasons. Alabama started the war in 1990 by suing to stop the plan to sell ownership in Lakes Lanier and Lakes Allatoona ahead of the water even being there to metro communities in the Atlanta area. So, unfortunately, Alabama is the only state in the water wars that doesn't have a comprehensive water plan. That's according to the Southern Environmental Law Center. Governor Bentley did release recently in 2014 an Alabama Water Resource Management policy, and that's a step in the right direction. But we don't have a comprehensive policy, and that weakens us in any legal battles. The litigation between Florida and Georgia, though, has spawned multiple lawsuits in multiple venues, and it's worked its way up to the Supreme Court of the United States. And currently, Alabama is on the sideline watching the litigation. We are not involved in any of the lawsuits that are ongoing right now. So here's the sticking point. According to the Southern Environmental Law Center, which is a non-biased party to the wars, Florida wants enough fresh water to reach the Apalachicola Bay to sustain its multi-million-dollar shellfish industry. And I will point out that oysters and crabs are both shellfish. It's under severe ecological stress resulting from low river flows and saltwater intrusion. Now, the Atlanta Regional Commission, and we know what side they're on, says that Florida must prove by clear and convincing evidence that Georgia's use causes real or substantial injury or damage to its substantial interests, including the oyster fishery in Apalachicola Bay. So here's the Apalachicola Riverkeeper on the steps of the Supreme Court, where he was part of an amicus brief to the hearings. And there's 5 questions that the Supreme Court decided that they needed to work through. They shunted it off to a special master that they appointed because there was so much data and information that needed to be understood to make a decision. He brought it back to the Supreme Court, and they sent it back to him and said, no, you used the wrong criteria for this. And so it's back to the Supreme Court. We believe they've answered questions 1 through 4, that Florida has suffered harm from decreased water flow, that Georgia has taken too much water out of the Flint River, that Georgia's inequitable use injured Florida, and that if there's a cap put on Georgia's use of water, then that will increase the flow into the Apalachicola River. They're still working on, will that extra water that reaches the river redress the economic and ecological harm that Florida has suffered? But there have been many minor victories and setbacks and surprises along the way, so no one has any confidence in which direction this will end up and who will win the war. But we know that the crabs and oysters probably won't win the war. They may survive, but they won't win. So why is all this fight over fresh water? Why is fresh water important? Well, estuaries are where fresh water and salt water meet. So when rivers flow into the ocean, where there's intermingling, when the salinity drops below oceanic strength, which is 35 parts per thousand, then that's called an estuary. And estuaries are difficult places for a lot of organisms to survive because the salinity changes frequently. And that creates osmotic regulation problems for a lot of organisms. Freshwater input has been shown to be a major organizing factor for numerous estuaries in numerous locations in the world, affecting what communities of organisms live there, which ones are dominant and which ones are not, which ones survive and which ones don't, overall productivity, nutrient levels. A lot of different factors hinge on that freshwater input. For the Apalachicola estuary, as for any other, when you decrease that freshwater input, it increases salinity. That's particularly important in Apalachicola because increased salinity favors oyster predators like this oyster drill here, a snail that has a little drill and uses sulfuric acid to assist that drill in drilling through oyster shells to kill and eat the oysters inside. I told you this was a war. It's not pretty. Increased freshwater input decreases salinity and is unfavorable to the young oysters that are coming in and settling down, so it doesn't favor oyster recruitment for the next generations. So what's best for oysters? Short periods of high salinity, short periods of low salinity, and fluctuations in the middle for most of the time. Now the oyster fishing down there has been going on with the same methods for over 100 years. And it's produced more than 90% of Florida's oysters for most of that time, and 10% of the nation's oysters, and they are very good oysters. I can testify from personal experience. Can I get an amen from anybody out there? Okay. In the fall of 2012, the fishery collapsed. They had a 77% decrease in the harvest, and the governor petitioned for and got a federal fisheries disaster declaration from the National Marine Fisheries Service, which doesn't help really with the problem as far as oysters. It just helps economically to the people who've been impacted negatively. From 1960 to 1992, the annual minimum Apalachicola river flows, that's the lowest flow over the year that the river produces, they were very positively correlated with the oyster harvest 2 to 3 years later. Why is that important? Well, 2 to 3 years is about the time it takes for the oysters to get from that settling larval stage to mature, reproductive, and delicious adults. So here's some of the oyster fishing boats that are idle by, no, these are actually shrimpers. Their boats are much more impressive. The oyster boats are usually small and old and kind of falling apart. So if we look at the freshwater input, so we've got two different figures here put together. The river flow is in blue, and here's the trend line for river flow, and you can see a steady decreasing line. The salinity at dry bar is the green. Dry bar is one of the two major oyster reefs in the Apalachicola Estuary. So that's your green, and that's got a lot of fluctuations as well, but a steady increase. So river flow is going down from 1992 to 2012, and salinity is going up over that same period. Here's the harvestable size oyster density on Cat Point, which is the second of the two major oyster reefs in the Apalachicola Estuary. Lots of fluctuations, especially in this period, but here's your drop. Here's 2012, a brief rebound, and then not a good show. So how did I get involved in the water wars? Well, the river keeper, the Apalachicola River and Bay keeper officially, asked me about crabs. Full disclosure, he's a personal friend that I've known for decades. His long-term girlfriend was a bridesmaid when I got married a long time ago. And so he started asking me all these questions about crabs and salinity, and I didn't even know what he was driving at first. But hours into our conversation, I realized he was relating it to the oyster problem. And he finally said, well, we got to get you down here to see how this is affecting the crabs here. And I said, well, I do have a sabbatical coming up. So I applied for and got a sabbatical. So I want to take this time to thank the Provost's office at Birmingham-Southern College for this sabbatical program, which allows professors to get some time away from the classroom, especially away from being on committees and doing clerical work, and to go back and do the kind of research we did when we were in graduate school, where you're totally immersed in it. It's a great experience, and I appreciate that it was made available to me. So my sabbatical was fall of 2017 and January 2018, and I started in June doing continuous sampling of crabs, working with the Fish and Wildlife Commission in Florida and with the Apalachicola National Estuary Research Reserve. These names are going to keep cropping up, so that's FWC and ANR. So until February 2018, we collected crabs together. Since then, they've been collecting crabs for me and putting them in the freezer, and I drive down there and get the crabs. They've also given me their huge data sets that go back to 1998 and 2000 for all the crabs that they've collected over those periods. In 2018, Hurricane Michael hit the Panhandle, and it destroyed the FWC lab. They had 3 months of frozen crabs for me, which were also destroyed. And they have lots of data that they haven't been able to get to me because they're still establishing a new office. So yes, I am a hurricane victim. What's the importance of blue crabs to Apalachicola? Well, the Gulf Coast blue crab commercial landings are 6 to 8 million a year. Not as much as the oysters, not as much as tourism, but it's a solid third place behind them, and that's not too bad. Sorry, I jumped ahead. But in 2018, Franklin County, which includes all the Apalachicola Estuary, the crabbers had their lowest catch per unit effort. CPUE is something we'll see multiple times in the rest of the slides. Catch per unit effort is how many crabs they caught based on the amount of effort they put into catching them. You can't just look at overall catch from year to year and make comparisons, because they might have put in less effort one year than another. If the price of gas goes up, they don't want to take their boat out as often, so they have less effort, they catch less crabs overall. If the price of crabs goes up, that they're getting paid for collecting the crabs, then they'll go out more. So they'll put more effort into it. So we normalize that by expressing our crab harvest as catch per unit effort. And it was the lowest in 15 years in 2018. It was the third smallest harvest in 25 years, even though crabs were bringing the highest price at the market. So a lot of crabbers were actually turning to other work at that point in time. The commercial crabbing there is not limited by quotas to protect the population and keep it high. What they do is they limit the number of people who have permits to do crabbing there. And they can collect as many crabs as they want to, but if they're not making any money collecting the crabs because there's so few of them, then they don't go out much. A little bit about blue crabs. So Callinectes sapidus is the blue crab. Callinectes is Latin for beautiful swimmer. Sapidus is tasty. Their adults are excellent osmoregulators. They can survive in any kind of salinity. They're found in hypersaline areas in Laguna Madre in Mexico, where the salinity gets up to almost double the ocean salinity. They're found in freshwater in Lake George in Florida, which is a couple hundred kilometers upstream from the mouth of the Jacksonville River, but it has a relatively high level of calcium for freshwater, so they can survive there. Their larvae are not good at osmoregulating because they're much smaller, and as all my organism students know, they have a much greater surface area to volume ratio, and that makes the osmoregulation much more difficult. So the larvae have to go through their life period, here's the larvae, in salt water. So let's go through the whole migration pattern that they typically experience. Adults mate in the upper reaches of estuaries where the salinity is low. Females will migrate down to the mouths of bays and they'll release their larvae into the open ocean where there's high salinity. So here's a female. They produce eggs after they mate with males. They have to molt first so that they're soft shell when they mate, and then the eggs get, the male deposits sperm in the female, and she holds onto that for up to a year until conditions are right for her to actually spawn. So then she'll fertilize those eggs, the eggs will develop into larvae, and she'll still be holding on to them in the first larval stage. Then she'll go down to higher salinity waters and release those larvae, and they'll spend about a month swimming around this tiny little plankton, depends on the temperature and other factors, and feeding on other little plankton. And then it will settle down to, as a megalopa, it'll move into an estuary and settle down to the bottom and molt into a juvenile. So that's the megalope moving to estuaries and morphing into juveniles, and then juveniles continue migrating into the upper reaches of the estuaries. Now, the first question you might ask is, how can these microscopic plankton move into estuaries when you've got rivers flowing out and going into a current? Well, it took a lot of effort to find how they do that. What they'll do is they'll swim up at the surface of the water when the tide's going in and drop to the bottom and actually hold on to something while the tide's going out. And then when the next tide comes in, they swim back up to the surface and move in. So it's a slow process, but they get in there. You may ask why they want to go up into the upper reaches of the estuary. Well, many different studies, because these studies are relatively easy, in many different locations have shown that the best food opportunities for blue crabs are in the upper reaches. There's much more structure and cover for them to hide from predators. And there's fewer of their predators can survive in the low salinity waters. So it's a way of escaping from predators. So this has been demonstrated for estuaries all over the U.S. But of course, Florida has to be different. So here's the peninsula of Florida, and their migration is different here. The adults will mate in the upper reaches of estuaries, but also anywhere along the coast in low, medium, or high salinity. You'll notice that once you get up above Tampa, there are no big estuaries or bays here for the crabs to go up into. There's limited estuary space. So Osterling and Adams did a study in the 70s, several studies in the 70s and into the 80s, where they put tags on crabs that were commercially caught at all the different estuaries along the peninsula of Florida. And the tags offered a financial reward for anybody who caught the crab and returned the tag to the researchers, as long as they could tell them where they caught the crab. So they released crabs here, 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 and here, but I didn't show you all the pathways because that would be too many lines to look at. We just picked out Crystal River here as one example. You'll notice all the lines are going in the same direction. Now the adult males stayed in their home estuaries. 95% of the males traveled less than 11 miles from where they were released. Females, on the other hand, these are all females here. And females from here traveled up and up and up. Females from here traveled up and up. And almost none of them went in the other direction. And if they did go in the other direction, it was a short distance. Very few of them went past Apalachicola. Most of them stopped at Apalachicola or got caught before they got to Apalachicola. Females went as far as 297 miles, and that 297 miles is straight line. They had to go along here to get there, so they probably traveled even further. And 9 females went more than 200 miles. They're thought to be spawning up here near Apalachicola. So that's where they're releasing the larvae. Why would they release their larvae there? Well, we don't know for sure, but the main hypothesis is that the Florida loop current comes along this way and then feeds into the Gulf Stream, which goes up the eastern side of the Florida. And the Florida loop current would pick up those larvae and bring them down in this direction. There's constant little eddies that come off the Florida loop current, and that would be giving them enough time if they got caught in any of those eddies to go through and finish their development and settle down. And once they get to the megalopa stage, then they start moving in, closer to shore and into estuaries. So that's our model for how they move along Florida, and that's supported in some ways by a number of the large number of mature females that have historically been found around the Apalachicola area, females that are carrying eggs and ready to spawn. So here's our research questions. Are altered salinity patterns in Apalachicola affecting the blue crab population? And there's 4 ways that we wanted to look at, that we hypothesized they might be affecting the population. The first was looking at their parasites and commensals. The next was, are they decreasing population size overall? And then we asked if they're disrupting the pattern of the population dispersion. So the dispersion is where they are in the estuary at different stages of their life. And is that pattern being disrupted? And then the last one is there decreased recruitment of juveniles from the Gulf of Mexico into the Apalachicola estuary? And in order to answer these questions, we needed to catch some crabs. So I worked with the Fisheries and Wildlife Commission Fisheries Independent Monitoring Program. So you can't rely on commercial landings to tell what the population is, because so many economic and social factors affect those things. So you have to go out and trap yourself, and that's what they do. So FIM and FWC will be used in the rest of the talk, because this is too long. They have a stratified random sampling program in the Apalachicola estuary. It's stratified because they divide the estuary into 3 main zones. Then they divide each zone into grids, but then each grid is randomly sampled. So it makes sure that all the different parts of the estuary are being sampled, but there's still random sampling, so you can use a lot of different statistical methods to analyze it that would be appropriate if your sampling wasn't random and was targeted at specific areas. They have 3 different kinds of sampling devices. They have small mesh seines. So here's people dragging a small mesh seine in the water. They have otter trawls, which are long nets. They drag behind boats, and it funnels everything into the a compartment at the back. That's a finer mesh, and collects them, and you got to pull the net back up onto the boat. And you might find a stingray when you do that. And they have long haul seines that 183 meters long. For those of you who are metric unaware, that's about 2 football fields, minus the end zones. You get 2 people to jump out of the back of the boat onto the shore with about 6-foot-tall poles and a 6-foot-tall net, and then the boat whips around, goes about a football field down, and comes back into the shore, and 2 more people jump off of the other end of the net, the 6-foot pole, and then you walk together, and then you pull the net up, and you get all the stuff out of it. So I asked them to collect crabs that they caught for me so that I could look at them for parasites, but I realized that I would get a lot more crabs from them if I went with them. So I started jumping in the water with them and catching crabs, and they would give me all the crabs that we caught, and when I wasn't able to get down there, or when 2 boats went out on the same day, the people in the other boats would keep the crabs that they caught for me as well. Now, the Apalachicola National Estuary Research Reserve people, or ANR, have a different sampling protocol. They use only the otter trawls, but they're very much the same size and all. And this is an Apalachicola estuary right here. So here's the town of Apalachicola, and they have stations. They started off with 12 stations, and they sampled them monthly from 2000 to 2012. And then they switched with Florida budget crisis when the governor decided that the environment wasn't all that important. They switched to quarterly sampling, and from 2014 to present, and they cut down to 9 sampling stations. So they go out to these stations. It takes 2 days to hit all the stations. So they're doing 2 days every 3 months now. They were doing 2 days every month, whereas the Fisheries Independent Monitoring Program from FWC is doing almost 2 weeks of sampling every month. So they got a lot more crabs. Not only do they have continuous visiting of these stations, not only do they visit these stations on a regular basis, they collect these data every time they do, and more. And they have 3 permanent data logger stations that record information permanently. So there's one over here, there's one by Dry Bar, and they monitor these things, and you can get the data online, or you can get it from them. They'll send you all the data in a spreadsheet as well for these values, and as well as weather and things like that. Now I put permanent logger stations in parentheses because the one that was up here in the East Bay, it's somewhere in the swamp here after Hurricane Michael. They haven't found all the parts yet. They're hoping to get funding to reinstall that, which would be great. In addition to the ANR and FIM collecting, we also got crabs from a local trapper. So that's Anthony Coulter. And not only did he collect crabs for us that the Bay and River Keeper paid for, but he also talked to us many times about what the crabbers' viewpoint is, what the crabbers were seeing, how the crabbers do their trapping. You can get so much information from those people, but they're kind of hard to talk to. Crabbers are like crabs. They're just protective and kind of hold back. You've got to take your time to get to know them. So let's focus on each one of these research questions one at a time. We'll look first at the population of the parasites and the commensals. So commensals are not parasites. They don't take nutrients directly from a host. They're thought generally to not damage a host. And these are ectocommensals, these barnacles here, because they're on the outside of the host. So these are gill barnacles, Octolasmis familiaris species. Here's the gills from one side of one crab, and you can see all these little attachment things are Octolasmis barnacles. So they attach to gills, and I said echoes on the outside. People generally think that gills are on the inside like they are on a fish, but the gills are actually the equivalent of being in the armpit and with the arm permanently held down. And so water flows in from below and then forward out, and that's how they ventilate their gills. So they're technically on the outside, but they're protected somewhat. And because they're on the outside, when a crab molts, it sheds the lining of its gills, and any barnacle that's attached to its gills is going to be shed too, and they don't survive. They're only found on the gills of crabs. They will go to other crabs, although blue crab seems to be their preferred, most commonly encountered host. So work I did previously showed that blue crabs that have this barnacle have elevated heart rates and ventilation rates. And if you stress crabs that are infested, they're much more likely to die from that stress than crabs that don't have the barnacles. But a difference between the barnacles and the crabs, or at least the adult crabs, is that the barnacles can't cause no regula, the larvae and the adults. So I showed that with a student researcher helping me for the adults, and it had been previously shown by someone else for the larvae. So here's a close-up with just one barnacle on a gill. So they attach to these are many very thin plates on the gill, and the water flows through them, which is a great surface area. So they cement, as barnacles typically do, they cement some of those plates together for their attachment. So here's our research methods. All the crabs that were greater than 50 millimeters collected during fin sampling, anal sampling, and commercial crab sampling were measured and sexed. Then they were immersed in water heated to 100 degrees C. Then their surfaces and gill chambers were examined for the number and location of barnacles. Muscle tissue was removed and immersed in a lipid-rich solution before it was consumed by the researcher and assistants, and then it was eluted with copious amounts of reagent-grade ethanol. So I'd like to thank some of the volunteers that helped with crab counting and barnacle counting. And I'd also like to thank Francesca for just about everything, including editing this presentation. Now let's go back to that 50 millimeters. 50 millimeters is a juvenile. With the males, you can't tell when they become an adult. Females, you can tell because the shape of their underneath carapace changes when they become an adult. But Fib and Aner one uses 80 and one uses 90 as their cutoff for estimating where the males are, and they just use the same thing for females because a lot of females get to that size and they're ready to make that final molt. They're just waiting for a male. Terrible, terrible. But that's the way they are. So we're looking for juveniles from 50, 80, 90, then above that they're probably adults, but we collected all of them. And I've just got time to show you only the infestation rates for Octolasmis and not the other commensals. So 9% of the crabs that we encountered are infested with Octolasmis. That's 400 when you take out the juveniles. So we didn't include the juveniles in this analysis. The juveniles are rarely infested by the barnacle because they would molt. They molt multiple times. As juveniles, they molt every few months. And so the barnacles would have trouble completing their life cycle. So it's generally thought by people in the literature that juveniles are never infested, but we wanted to test that by going out and collecting juveniles to make sure. We did find juveniles that were infested, and I even found a mature reproductive barnacle inside an immature juvenile, which no one's ever reported that before. But they were very rare. So we left the juveniles out of the analysis. So our sample size dropped from 580 down to almost 400. So 9% infested. For males, it was 10.4%, and our sampling was biased towards males for this part of the study. We're not sure why. Seems like the collections that we made in other ways were not biased towards males. Females only had 5.8% infestation rate of the barnacles. Let's look at how that was distributed, or how that compares, rather, to other estuaries. So this is our results here: 9% infestation, 10% males, 6% in females. And the salinity range of uninfested crabs that didn't have barnacles, was all over the gamut. 0 freshwater, 35 parts per thousand cool spring ocean water. We only found barnacles in crabs that were from waters that were 5 to 35, but very few, as you see on the next slide, in that low end. A previous study I had done in Seahorse Key with a large sample size found a 39% infestation rate, heavily biased towards males, and a higher salinity range. When I was at Gettysburg College, I got a crab sample from Chesapeake Bay because I wanted to look at low salinity waters. People hadn't looked to see if the barnacle was found on crabs in low salinity water at that point. And so we got a relatively big sample, although it was just one day of sampling that the Virginia Institute of Marine Science did for me. But a very low infestation rate because the salinity was very low. So in the 8 to 22 parts per thousand, the fresh and brackish water, they were all uninfested. Only a couple were infested, and they were from the small number of crabs we got from higher salinity water. When I was at Nicholas State University in Thibodeau, Louisiana, I got a sample of crabs from Lake Barr, 174. That was a low salinity, and there was only 2 infested crabs in that sample. And they had like 1 and 2 barnacles on them. This compares to earlier studies at the Beaufort Inlet in North Carolina with a very high infestation rate and slightly higher for males than females. The salinity is unknown, but based on the site where they collected them, it was probably pretty high. Depends, of course, on the tide and things like that. But this was a non-random sampling. That's why they got such high numbers. They looked for external barnacles on the outside of the crabs and picked those crabs for further study. And the outside barnacles are different species, and the inside barnacles typically co-occur in crabs. So they were biasing the sample there. A really early study from 1941 with a large sample size found a much higher percentage as well. And this is Grand Isle, Louisiana, which is like the furthest out in Louisiana you can be and not be in the Gulf of Mexico. So that was high salinity. So here's what happened when we looked at the salinity ranges that we found crabs in and the infestation rates. So highest infestation rates at the highest salinity, and we break it down into 5 parts per thousand ranges. Higher infestation rates here, none here, but a very small sample size at that range. And we had low, these are only one individual, but there was low sample sizes here, so that one individual stands up as a relatively high infestation rate. And then no infested crabs at the lowest level. We did have a big sample size here, but no infested crabs. So we did a binomial regression, and we found that salinity, sex, and size are all significantly correlated with infestation by Octolasmis, that males are more likely to be infested, that larger crabs are more likely to be infested, and that higher salinity water crabs are more likely to be infested. And these were not unexpected things. What was unexpected was we found 2 crabs here that are not in this figure that had barnacles in their gills, because the barnacles were all dead. There was nothing left of them but traces of their exoskeleton. And there was 1 crab here that had all dead barnacles inside it. The ones that we did catch here that had barnacles, there was 1 live barnacle and 19 dead barnacles in this crab. And this one had, those were all live in that one. But he could have gone into that water relatively recently. So from the Ectocommensals study, what we have to conclude is we don't have enough years of data, of course, to determine if the percentage infestation is changing, because no one's ever done a study there before. So this is our first year there. The barnacle infestation rates are relatively low when we compare it to other estuaries, though. The infestation rates correlated with increasing salinity. And as I said, we found mature barnacles in juvenile crabs and some crabs in low salinity waters with dead barnacles inside. So this does support the hypothesis that a reason for moving into freshwater could be to minimize negative impacts from commensals. So these are some of the crew I went out in the boats with collecting crabs. And we'll look at population size next, and then we'll look at the dispersion pattern. So this one is not from the research scientists. This is the commercial harvest in Franklin County to show what the crabbers were actually seeing. So this is from 1985 to 2017. And we've got the pounds of crab harvested is our blue line, and there's our blue trend line. And this is the value, the orange one, which is just the dollar amount that they get paid for bringing the crabs in, multiplied by the pounds that they collected. And we don't have a trend line for that. That depends so much on economics that we're not interested in that. But we are interested in the catch per unit effort, which is our gray line, showing lots of variation, but showing a downward trend as well, especially the last few years. So that's what the commercial crabbers were seeing, and that's why some of them were getting out of the business. But if we look at the trend in the National Estuary Research Reserve people, their catch of blue crabs at all salinities from 2000 to 2018. So we do have 2018 data from them. We see a lot of fluctuations. This looks like a downward trend, but that R-squared value is so low that it's really not a significant trend. But this includes all the juveniles. And the crabbers were more interested in adults than juveniles. So we took out the juveniles and looked at just the adults. And this is a much lower numbers. If you looked at the scale in the last one, this was like 10, 20, 30, 40. For the adults, it's 1, 2, 3, 4. Because you catch a lot less adults than juveniles, because a lot of juveniles don't survive to adulthood. So our catch per unit effort here at all salinities, and this is a pretty large sample size, 1,900 crabs, but it is over almost 20 years. Lots of fluctuation. Lowest numbers are these years, but then there's high numbers right here. Now, these collections are, as I said, done on 2 days, 3 times or 4 times a year. So they're more subject to random events than the FIM effort, which is done every month for almost 2 weeks. And this is the largest sample size I've ever had, 23,911 crabs over more than 20 years. So, but it stops in 2017, and that's a problem. The 2018 data, I expect, are going to be really low. I know that when I went down there to collect crabs that they had in the freezer for me in the earlier parts of 2018, they'd give me a Ziploc bag with 2 juvenile crabs in it, and that would be it. When I went down there previously, I'd get a cooler full of crabs to look for parasites in. So this is from 1998 to 2017, and these are the adults down here. You can see, again, much lower. Here's the juveniles. But we've tried to correlate some of these population levels with environmental events. There's Hurricane Ivan, there's Hurricane Dennis, Deepwater Horizon, there was a big drought, 2011-12, Hurricane Hermine. Hurricane Dennis is thought to have removed almost all of the submerged aquatic vegetation in that estuary. And multiple studies have shown that submerged aquatic vegetation is essential for the crabs, especially the juveniles, as something to feed on and something to hide in, and something for animals they feed on to feed on. And yet, the year after that, this was in 2005, which that's hurricane season, that's going to be late in the year, almost in 2006. 2006 was a spike year. All the records we have, historic, on crab numbers, whether it's Ainer, Fin, or the commercial engine, show a big spike in 2005, right after that hurricane. So, it's hard to predict from the environment. Yeah, the drought showed a big decrease in the population, but these other events don't seem to have had much effect. And the Hurricane Dennis seems to have had the reverse effect. So if we look at just the adult crabs from that previous figure, we see a lot of fluctuation, but we don't see a big decrease in the last few years. This is well within the normal range. So this is the FWC data. So we have to conclude that the populations fluctuate greatly, particularly with environmental events, but sometimes it seems logical and sometimes it seems irrational which direction the population goes. Juveniles make up the bulk of the population, as you might expect, and they fluctuate the most. The commercial harvest shows a strong decreasing trend, but the Ainer data shows very high and very low adult populations, and the FWC data is lacking for that last year, which is important. Let's look at the dispersion patterns and how they were affected, and it was below freezing that day. And I was out in the water. The water was warmer than the air, so it was nice to get in the water, but then you got to get out. And then it gets really cold. So the dispersion pattern shows, based on salinity, that all, the juveniles, the males, the females, big decrease. So high salinity waters are not where you find the most crabs. This is adjusted so that 1 is the overall average. So anything above 1 is above average, and anything below 1 is well below average. So this tells us, with a sample size of 9,000, almost 10,000 crabs, that they are found most often in low salinity waters. That's got to be where they're surviving the best. Now the FIM data aren't as steep, but it shows the same trend. Our peak is in the second category, 5 to 9 parts per thousand. But again, all of them with a little spike in the females over here in the higher salinity waters, but still higher in middle salinity waters. So again, we're looking at crabs preferring the low salinity waters overall. And so what we have to conclude from this is that the increase in salinity of the estuary does pose a threat to the crab population, but we've got a lot more data that we can analyze to look at this in more detail. Our last question was about recruitment of juveniles into the Gulf, into the estuary from the Gulf. So ANER started quarterly plankton sampling in addition to their other sampling, and we wanted to know if the population may be impacted by not enough juveniles coming in to the estuary. So Catherine Odell, who's graduating this year for her senior research, analyzed some plankton samples that ANER had collected. And what she found most often was copepods. Lots and lots of copepods. How many copepods did you count? Thousands? Thousands of copepods. Well, we were looking for these guys. She did find some. 7.2% of the crustacean larvae were Callinectes zoea or Callinectes megalops larvae. But we realized, kind of after she finished all the counting, that these are much more likely to be found in the lower water levels, and these plankton trials were done in the surface. So we would find some there, but we wouldn't expect to find most of the crab larvae in there. This is not much lower than what's found in the only previous study of plankton in Apalachicola, but we have a baseline. So they have 2016, 2018 data, so we can compare them and see if there are any trends. So, conclusions. Water wars. Will the Apalachicola blue crab survive? Yes, crabs are really tough. They're feisty. They're most dangerous when they're cornered. Their population has shown the ability to rebound. It's a great estuary. It's got lots of nutrients. No, they prefer the fresh water. They don't do well in the high salinity water. Their parasites get to them. Their predators get to them. If that water is not changed, that water inflow is not changed by the Supreme Court, they're going to disappear. And oysters have crashed, and juvenile oysters is one of the things they like to eat the most. Sorry, jumped ahead. Maybe both of these things will happen. Or, I don't know. You can decide. This is a do-it-yourself adventure. Now, I really have to acknowledge the help of a lot of people. The riverkeeper came up with the idea in the first place and gave financial support and a place to stay when I was down there. This is the part of the crew from ANER, with Jason Garwood as the lead of that lab, and they took me out and helped me collect crabs and collected crabs for me when I wasn't there. Sorry, going the wrong way. The FWC crew, Dave Gannon in charge of them. All these people went out with me and pulled those heavy nets. Got bit by crabs and stung by stingrays. And then I got to acknowledge the biology faculty for taking care of my advisees while I was gone and teaching my classes while I was gone. And the two senior research students, and we mentioned Catherine Odell, Jonathan Scaringe, graduated last year. He looked at infestation rates and salinities, but he had a much smaller sample size to work with before he graduated. So I hope you'll ask some questions. Yes?
At what age do crabs become able to osmoregulate?
That's a good question. When they get to the megalope stage and start moving up is when they acquire that ability. Dr. Gibbons.
Why do you consider the gill barnacles commensals and not parasites if they're actually having some negative impact on them?
I have made that argument at scientific conferences before, and most people have disagreed with me. I call them respiratory parasites because they can harm the host by blocking the respiratory stream that's ventilating the gills. And when you open up a crab that's got 600 barnacles in its gill chamber, and that crab is looking all weak, scraggly, you know that it's harming the crab. But the definition of parasite, for most people, does not hinge on harm, it hinges on taking nutrients directly from the host. So, I agree, they can have a strong negative impact. On the other hand, if there's only one or two barnacles in their gill, they seem to do really well. I exercised crabs that were infested, thinking that since their heart rate and ventilation rate are increased by the infestation. So I said, hey, if they exercise, then there'll be a limit on how much more they can increase their ventilation to overcome that. Well, what I found was that blue crabs are the sprinters and marathon runners of the arthropod world. They are not bothered. They just increase their ventilation rates to super high levels, and they keep on trucking. And they can swim 1 meter per second. Catherine, how fast can you swim? Laura?
Is the red tide in Florida affecting any of the crab populations along the coast and the ability to live crabs?
Yeah, the red tide has affected the lower part of the peninsula. They're not doing any tagging studies there right now. They are doing a big tagging study that's focused on the western Gulf of Mexico. So they don't know the impact, but the red tide is something that they've been very nervous about for the last summer. But it hasn't gotten up nearly to Apalachicola, nowhere near. These are great questions. Got any more?
Some people might not know what red tide is.
Oh, yeah. So red tide is caused by dinoflagellates, algae-like things, single-celled organisms that have population blooms in many places, particularly in the Gulf of Mexico, that use up, when they die off from these big population blooms, the decomposers use up all the oxygen in the water, and that kills a lot of things, but they also release a toxin, dinoflagellates release a toxin that you can walk along the beach with the wind blowing off the water and make your eyes burn because some of that toxin is in it. So they have big fish kills from them. And so there was an outbreak this summer in the southern part of the peninsula. They kept moving northward. And my colleagues were constantly checking on the maps to see how close it was coming.
Okay. Is anything you mentioned going to affect the predators of the blue crabs, or there's still enough juveniles that it doesn't yet?
Well, that's another great question. You guys are doing great. I wish you were all in my class. The thing with the blue crabs is their predators are everybody. There's so many predators on them, so they can all switch to something else. Yeah, natural predators are any fish that's large enough, any bird that's large enough. But once they get to the adult size, it's large and feisty for most fish and most birds. So it's really the juveniles. And the biggest predator on juvenile blue crabs, adult blue crabs. Savage animals.
Route they have to move up out of the estuary into more fresh water. If the encroachment's coming from the ocean, so there's less fresh water flow. If they adjust simply by moving.
Yeah, that's a great question, and that's something that I cut out in order to finish on time, and I guess I did, so great. So they can move further up and get into freshwater, being like the Apalachicola River main stream. The problem is that's a very limited area. And it's steep banks. I know because I jumped off the boat onto the bank, thinking I was on the bank, and then started sliding down. So that's a much more limited area. In the estuary, which is big and flat, it's a very broad area, and there's lots of tidal channels and vegetation and places to hide. So they can survive, and they will survive, but the population is going to decrease. They have to go far out. Another thing is during flood stages, which happen with tropical storms and hurricanes, the current coming down can be so strong that it blows them down back into the lake. More questions?
I'll give myself the last question. So the salinity rates in the estuaries, is it like an immediate impact if that fresh water comes down, it's gone? I mean, it changes now? Or is there salt, so to speak, is going to be in the base?
Yeah, so what happens is the high salinity water is denser. And so the fresh water flows across the top, and it creates what's called a salt wedge. And the salt wedges in Apalachicola Estuary are the sharpest I've ever seen. You can be on a boat in 4 feet of water, and you put your salinity meter over, and right at the surface, it says, this is pretty much fresh water. It's like 2-3 parts per thousand. And then you drop it down a meter, and this is 26 parts per thousand, and you drop it down 2 meters, and it says, this is 35 parts per thousand. So it doesn't ever wash it completely out in estuary, but it'll push that salt ledge back.
All right, with that in mind, I think I'm a timekeeper, so I'd like to give one more hand